And later today, I'll put on both this class and the class from yesterday. First of all, final exam. I hope everybody knows is on May 20th. That's next Thursday. I don't know what's with this thing that it's squeaking. So from 10 a.m. till noon. And it's on Blackboard. Again, it's not on Zoom, it's on Blackboard. If you have any problem, you get locked out or you get bumped because of your internet, just email. I'll be available from 10 to 12. I'll be available for you to do that exam. And if you run into any problem, I will restart. The only thing I have to tell you is that if you got locked out and I have to restart, there's no way I can have you continue. You're just going to have to redo everything from the beginning. I know that that is a problem that I haven't solved when it comes to the Blackboard tests. On Delta Math, I can restart, just restart some of the questions, but I don't know how to do that. I don't know that it's possible to do that on Blackboard. Okay, so you wanted me to do some questions that have to do with linear equations. Let me see if I can find some things from Okay, so let's say take a question like this. Suppose I asked you to find the slope. First of all, what if I gave you 2 points? Suppose I gave you the point 2, 2, and -4, 3. And I said I wanted you to find the slope of this line. See if you can find the slope. Give you a minute to try that. Okay, if you remember how we do the slope, the formula for slope is y2 minus y1 over x2 minus x1. And we call one of our points x1, y1. It doesn't matter which one, but the other one then becomes x2, y2. And if I stick those numbers into this formula, I'll get 3 minus 2 at y2 minus y1 over negative 4 minus 2, x2 minus y2. So the 3 minus 2 is 1, negative 4 minus negative 2 is negative 6. The slope of this line would be negative 1 over 6. Okay. Stacia, do you want me to do other types of questions, like how to
Would
write?
you like, yeah, like how would you plot that on the graph? That's the only problem I'm having, the graph one.
First of all, you have to understand that, you mean, how would I graph this line?
Yeah,
Well, are you talking about on Delta Math, or are you talking about the final on Blackboard?
on like on finals, how would we
Okay,
graph
on the
it?
final,
Mhm.
it's all multiple choice. They'll give you different pictures and ask you to choose it. Now, in this case, this one would be easy because all you'd have to do, they wouldn't even ask you to graph this because they're just giving you 2 points. But
Okay.
let's say they gave me something like this. Let's do another one. Suppose they gave me the equation of the line. Let's say they told me I have 3x minus 2y equals 9. Let's say they gave me that equation. And they said, I want you to graph that line. So the first thing you're going to want to do is put it in what we call the yn equals mx plus b form. We want to get it into the standard format. So we have to bring the 3x to the other side. So that'll leave me negative 2y equals negative 3x plus 9. And then I have to divide everything by negative, I really should have changed this. I didn't want this to come out to be, because they're not going to give you 1 with a fraction. I'm going to make it an 8. So I'm going to divide everything by negative 2. So in y equals mx plus b form, I get negative 3 over negative 2. Well, negative over negative is positive, so it's 3 over 2x. And 8 divided by negative 2 is negative 4. So in this case, my slope is 3 over 2, and my y-intercept is negative 4. So far, okay?
Yes, Professor. Yeah.
So now if we wanted to graph this, here's what we would look for on the graph. Here's my x, here's my y. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. When you're going to graph it, the first thing you're going to look for is the y, which is right here. It's negative 4. That's where the line is crossing the y-axis. Then we use the slope to find another point. The slope is
rise over run.
3 over 2, which is rise over run. Means from here, from that point, you rise 3, 1, 2, 3, and you go 2 over, and you make another point there. And you could do this as many times as you want. You could now start from this new point and again go 1, 2, 3, and 2 over. And if you notice, here's your line. Now, again, on the final, they're not going to ask you to draw a line. You're just going to have to pick out the right line. Remember, when your slope is positive, the line slants to the right. when your slope is negative, it slants down. It goes to from left to right, it goes down.
Okay, understand now, Professor. Thank you.
Did you have anything else you want me to do with, anybody else have any questions about lines or anything else? Any questions on any topics? I would like to review just how to solve quadratic equations. I think that's the one topic we didn't go over yet. And then let's review that. And then what we'll do is I'll just give you different problems and give you time to work them out. It's similar to what you'll see on the final, maybe a little bit different than the practice final. Again, what I did is I went and I extended the deadline on every single homework, test, and quiz until 10 o'clock on 10 o'clock a.m. on May 20th. So if you still have things that you haven't done, you'll see there, they may say late date, but don't worry about that. If you get, because you get 90% of your credit for it, even if it's late. And most of the time, I just excuse the lateness. But every single homework and any assignment of any kind is open to be done until the final exam. You're not getting a good mark in this course if all you did is the midterm and the final, because then 40% of your mark is not being counted. And there are people here who have almost no, they got a good mark on the midterm, but they didn't do any of the other work. And that means they're really probably failing the course if they don't do any more work. So don't fail the course because you didn't do the homework. Okay.
Teacher, can I say something to you really quickly?
Yeah, sure.
Oh, because you said like today is our last day. I just want to, from my perspective, like thank you like for being a good teacher, because even though now since we're in Zoom we can't see each other face to face, I know at times it was a challenge early on to with the connections and Zooms and developing relationships with your students. But just thank you for being such a good teacher and being very understanding, but also actually wanting your students, wanting us to do good in school, because there's not a lot of teachers, I can honestly say from my perspective, not a lot of teachers who really go above and beyond for the students like you did. So from my perspective, thank you. I appreciate it.
John,
Yes, one of the best professors I ever had.
Oh, I didn't mean to.
I second that, Professor. You, out of all my professors that I have, you are the best professor ever. Like, I would, hands down, I wish that there would be more professors like you.
Yeah.
Hands down.
I wish we had her again. Honestly.
Yes, I wish you was like our professor for math 155 when we have it, or whatever the hell it is after this.
Yeah, me too.
You don't have
Thank
to go to
you so much.
155, only 151.
Yeah.
Oh, I thank you so much.
She's just the best. That's it. She's
I had
the
to
best.
tell you, as I said, I've been teaching a long time, and since last March, I got this taste of teaching online, which I was totally unknowledgeable about. And the first couple of terms, I really, especially last term, I really felt like I was talking to the wall. I would put the problems on the board, but there was no response for this class has been a great class. You've been responsive, you've been involved. It's almost like being in a classroom setting without, it's as close as it could be without being in the classroom. I really wish I could have come into school and met each of you in person, because I really feel that you're involved and you're going to be successful in whatever you do because you try so hard. And I really have seen how people have grown in this course, and I'm very happy. That's what gives me satisfaction. My satisfaction. People tell me, how can you not be burnt out from teaching so many years? I said, well, I've been teaching so many years, but every time it's different students. And really, it's you who make the experience what it is. So I
And
really
Professor,
thank you.
if I
All of
may,
you.
it's like
Thank you,
at first,
Jonathan.
No problem. Anytime.
when I started, I was like, I am not going to pass this class. I do not like maths. And then I'm like, I'm getting all these 80s and 90s. I'm like, what? This professor is
And
the
I hope you
best.
like it better also. I always, when people tell me I can't do math, I said, you didn't have the right teacher. Because everybody could do math. And it's so important to be able to do this because it really trains a different part of your brain. It's a different, and it's not just memorizing words or facts. It's really training yourself to think logically, and that's very important, especially with our politicians nowadays and a lot of things they say that are so illogical. Doesn't make sense, but really math makes sense. Okay, so now I was going to do a quadratic equation, I think, unless somebody had something else they wanted to ask me. Okay. Um, I really should, I should record this so that, and send it into the department. But really, this is really, when I have a good class, the class is, it's because of the class. It's not because of me.
Yeah. It's good because I think everyone in this class, we work together. And if anyone is stuck, we actually lend a helping hand. And Cheryl always tells people congratulations and gives words of encouragement. So that's good. And yeah, it's good.
Yeah, I've always found that my best classes are the ones that became a group and worked together. It's really important to help each other and work together. You really made my life easy. Okay, so I think I was going to talk about a quadratic equation. Um, let's say I gave you this equation. Okay, let's first start with what looks like a really easy equation, but I want to remind you how to do that. You can see it's the end of the term. My markers are all running out. Suppose I gave you 4x squared plus 36 equals 0. Okay. I'm going to give you a few minutes to solve this equation, this quadratic equation. It's really what we call an incomplete quadratic equation because it doesn't have an x term, it just has an x squared. Let's see if you can solve that equation. Okay, let's do this together. This type of equation can be best solved by what we call the square root method. Solve for x squared. Get the 36 to the other side so that you get 4x squared equals negative 36, and divide by 4 so that you get x squared equals negative 9. So when you have just an x squared term, if you don't have an x term, then you can solve by just finding out what the x squared, pretend this is an x and solve it. Of course, you're not finished over here because when it says x squared equals negative 9, you have to take the square root, you have to do plus or minus the square root of negative 9. Don't forget you have to do, unless it's on a graph and you can't get a negative, then you have to do the positive or negative square root of negative 9. And remember, the square root of negative 9 is 3i. So your answers are plus or minus 3i, which could be written like this with this special symbol, or separately 3i and negative 3i. So this is a relatively easy square root, a quadratic equation to solve when you do not have a x term. Even if you can't factor it, you can solve it. But what happens if you have something like this? Let's say I gave you this question. X squared plus 8x equals 4. Let's see if you can solve that quadratic equation. Give you a few minutes to do that. Okay, Stacy, you just wrote 3 and negative 3. Remember it because there was a negative inside the square root. It makes it 3i and negative 3i. Don't forget that I. If it would have just been the square root of 9, the answer would have been 3. But because there's a
Negative 9.
that's where you got the I from.
Okay, no problem.
Okay, good. Okay, while you're doing that, I'm going to take attendance this one last time. Well, I guess I'll take attendance at the final also. No, I won't. I'm not going to take attendance because you're going to be online. Okay. Let me just mention that if you have any questions, you can always email me the questions. I'm not going to be available Monday and Tuesday, but Wednesday, a whole day, I'll be available. So if you have any questions, just email me. I'll check early on Wednesday morning, and then I'll check periodically during the day. If you have any questions and you need some help, just email me. And if we can't do it on email, then we'll get it together on Zoom. I can always set up a Zoom session for you. Okay, Azia, Nashia Allen. Nashia here? Annabelkis. Emma Benedict. Messiah. Corey.
Here.
Hi, how are you? Were you here yesterday, Corey?
No.
Oh, okay. April.
Good morning.
Good morning. Khadija? Khadija here?
Here.
Oh, good morning.
Good morning.
Umar? Yakima? Cheryl, I know you're here. Stacy, I know you're here. Denisha? Denisha?
Present, Professor. Good morning.
Okay, you're not Denisha though.
No, I'm sorry because I was helping my daughter. I didn't know if you called my name.
Okay, you're next, Devon.
Okay.
Okay, good. Natalie. Natalie. Erica. Jonathan, of course, I know you're here. Luke. Layla. Ashley. Kachira. Kachira.
Here.
Oh, I thought you were here. Jennifer, I know you're here.
Here.
Rachel. And Gloria. Okay, let's see.
Hi, Professor. It's Nashia. I got disconnected like
Oh,
a few
good.
seconds ago.
I'm so glad you're here.
Good morning.
Okay, now let's see. According to this, I have 12 people. 1, 2, 3, 4, 5, 6. Yep. Okay. Okay, I see Jennifer has given us the answer. Let's see if what answer we come up with. Okay, so I'm going to erase this and I'm going to work on that question. Jennifer, which way did you do it? How did you solve that equation? Did you use a formula or did you use the completing the square? Hello, Jennifer?
I subtracted both sides of the equation by 4.
Oh, you in other words, you use the completing the square.
Yeah.
Okay, so let's do it that way. You know what? I'm going to do it both ways, as a matter of fact. Oh, okay. So we have x squared plus 8x equals 4. And you subtracted 4 from both sides. So you got it equal to 0. Okay. And did you then use a formula? Okay, let's remember the formula. The formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is what's called, remember, the quadratic formula. It's probably the most important formula that we learned this year. Again, if you're going on, and I'm sure a bunch of you are, if you're going on to Math 151 pre-calculus, probably the first formula you're going to be using is this, and you're going to use it through any math course. Even if you're majoring in math, it's probably your most popular formula to use because it'll let you solve a quadratic equation. In this case, the a is 1 because that's a number in front of the x squared. The b is 8. That's a number in front of the x. And the c is negative 4. That's the standalone number without any x's. If I stick this into my equation, I get negative 8. That's in place of the b plus or minus. Okay, here's my -8, here's my b squared minus 4. In place of the a, I'm putting 1. And in place of the c, I'm putting -4. And this is all over 2 times 1. Okay, so I just stick in the numbers. I write down what the a, the b, and the c is. I stick in the numbers. Okay. Now, the big thing is to make sure the number inside the radical is simplified. So let's see. This is -8 squared. So -8 times -8 is +64. -4 times 1 is -4 times -4. So -4 times -4 is +16. And 64 plus 16 is 80. So this turns out to be -8 plus or minus the square root of 80 divided by 2. And the square root of 80 has to be simplified. Now, remember the square root of 80, let's do that over here. We could break that up into 16 and 5. And the square root of 16 is 4. So I can rewrite this as 8 plus or minus 4 radical 5 over 2. And since both the 8 and the 4 can be divided by the 2, remember, if you can divide by the number on the bottom if it goes into both terms, not just one, but in both of them. So this becomes 2 into 8 is 4, plus or minus 2 into 4 is 2 radical 5. And I think that's what you had written. Okay. Any question about this? I want to show you that we could have
Could you go
also,
over it one more time? Sorry.
yeah. You want me to go from the beginning?
Yeah.
Okay. I'm going to do this and then I'm going to redo it a second method, okay?
No problem.
Okay, so if I'm going to use the quadratic formula, I have to get it equal to 0, which I did. And here's my quadratic formula. Should I erase this and just redo it? Would that
Yeah.
be cool? Okay.
Yeah.
Okay, I'm gonna. Let me put the formula over here. X equals -b plus or minus the square root of b squared minus 4ac all over 2. Okay, this is called the quadratic formula. Don't forget it. You can use it to solve any quadratic equation as long as it's equal to 0. It has to be equal to 0. It wasn't equal to 0, that's why we had to get it equal to 0. So if I look at it, the a is the number in front of the x squared. Since there's no number in front of the x squared, it's understood to be 1. The b is the number that's in front of the x, which is 8. Notice it's really a positive 8. Don't forget that the sign goes with the number, but I don't have to put the plus sign in. And the c is the number that doesn't have any x next to it, which is -4. And here's I stick it into my formula. So it's -b. So here's my negative and here's my b. My b is 8 plus or minus the b squared, so that's the 8 squared, minus 4 times 1 times -4. This a is my a is 1 and my c is -4. And that's all over 2a, so 2 times 1. Okay, so far okay? All I did was I took it and I substituted into the equation, into the formula. Now I have to simplify this. So this is a -8. And this is plus or minus. Okay, 8 squared is 16. This is all in the square root now. -4 times 1 times -4. I multiply all these three together, gives me, I'm sorry, 8 squared is 64. It's not 16. And the -4 times 1 times -4 is plus 16 over 2. And 64 plus 16 is 80. You just add those up. So this becomes -8 plus or minus the square root of 80 over 2. And the big thing is to make sure to simplify that radical. The square root of 80 can be simplified. 80 is 16 and 5. So the square root of 16 is 4. So the square root of 80 simplified is 4 times radical 5 over 2. And now I just divide each of these by the 4, by the 2. -8 divided by 2 is -4, plus or minus 2 into 4 is 2 radical 5. -4 plus or minus the square 2 radical 5. Is that clearer?
Yes, no, yes, Professor, thank you.
Okay, I'm gonna go back and I'm gonna do this using the completing the square method. A lot of quadratic equations can be solved using this, what we call completing the square, where what you have to look for is that the number in front of the, first of all, the a has to be 1. There can't be a number in front of the x squared, which we don't have. It's understood to be 1. And the number in front of the x has to be an even number. This is 8, it's an even number. In that case, I can use the completing the square method. You don't do both of these, you can do one or the other. Again, the quadratic formula method can always be used. The completing square method you use when you have a 1 in front of the x squared and the number in front of the x is divisible by 2. It's an even number. Okay, here's going ahead and doing it with that method. You'll see we'll come up with the same answer. I find that the completing the square method is probably easier if you can use it. Okay, so when you are completing the square, you want the x terms on the left side, and any number that doesn't have an x you want on the right side. So you don't want it equal to 0, you want to have it equal to a number. And what you do is you take the number that's in front of the x, which in this case is an 8, divide it by 2. Well, if I divide 8 by 2, I get +4. And you multiply that by itself. You square that number. So 4 times 4, let me just usually leave a space. So we're going to add, it's completing the square because we're going to add something to make it from a binomial into a trinomial. So half of 8 is 4. 4 times 4 is 16. I add 16 to both sides of the equation. Now this then becomes x plus 4 squared. That's the whole point. We made this into a binomial squared, and it's always The first term is always going to be x, and the second term is always going to be this number divided by 2. Remember, it's a positive because this was a positive 8. On the other side, what we get is 4 plus 16, which is 20. And now we take the square root of both sides. So on this side, we just get x plus 4. And on this side, we get plus or minus the square root of 20. On the side that doesn't have the square, you take the square root, but don't forget to put the plus or minus in front of it. Now, the square root of 20 can be broken up into 4 and 5, which is 2 radical 5. So this becomes x plus 4 equals plus or minus 2 radical 5. And now just bring this 4 to the other side. So we get x equals negative 4 plus or minus 2 radical 5, which is exactly the same answer we got before. If you notice, we did a lot less steps because completing the square where it works really is a simpler method. All right. See, some more people have joined us. Khadija. Okay, Layla. Luke. Messiah.
Fro, did you say my name?
Yeah, I just saw that you were here, so I changed you from absent to present.
Okay,
Okay.
thank you.
All right. Are there any other questions anybody want, or any topics somebody would like me to go over? Or should I just,
Can you go over the hyperboles? Like all of the graphs, hyperboles, and the other two?
the different graphs, what they, right, okay, that's a good thing to go over, okay. I'm gonna do an example of each type. Okay, let's say I gave you this. Y squared over 4 minus x squared over 25 equals 1. Okay, see if you can sketch that graph. See if you can sketch that. I'll give you a couple of minutes to try it. Okay. Let's look at this. If you notice that we know this, when we have x squareds and y squareds, that's when we have one of what we call our conic sections. Either a circle, ellipse, hyperbola, or parabola. This happens to be a hyperbola because it has a minus between the x squared and the y squared terms. And when we get a hyperbola, we get these two back-to-back U shapes. Sometimes they're sideways U's, sometimes they're U's that are up and down. And the way we decide which it is we look for the one that's positive. In this case, the y squared is positive, the x squared is negative because it has a minus in front of it. In that case, we're only going to have y-intercepts. So when the y squared is positive, you have y-intercepts. If it would have started out x squared minus, and the y squared was negative, you would have had x-intercepts. Okay, and the way we find the y-intercepts is we look for the b squared. The b squared is the number that's underneath the y squared, which is 4. So that means if b squared is 4, that means that the b has to be either plus or minus 2, which means your graph is going to look like this. You're going to go up 2 on the y-axis, you're going to go down 2 on the y-axis. And you're going to get these u's. Here's one u, it's a regular u, and here's your upside down u. Always when you're looking for the hyperbola, make sure you find the one where it's crossing the right axis and at the right point. It has a y-intercept because the y squared is positive and the intercepts are plus or minus 2 because b squared was 4. Any question about that?
Can you say the last part? What was the last thing you said? Sorry.
What was the last thing about
In relation to the graphing, you said something. I missed it.
this graph?
Yeah, the graph that you just sketched.
Yeah. Whenever you're looking, again, you're going to know that you have a hyperbola when there's a minus in between the x squared and the y squared term. And it's very important to focus on which one is the positive one. One will have those, usually it's the first one, will be positive, the second one is negative. But if they had written negative x squared plus y squared, look for the one that is positive. Look for the one that doesn't have a minus in front of it. In this case, it's the y squared. So you take the number under the y squared, which is the b squared. B squared is 4. That means the b has to be plus or minus 2. And it means that your two y-intercepts are positive 2 and negative 2. And that's what you're going to, I think this is what I said, Jonathan. That's what you have to concentrate on. Make sure you're getting the right intercept, because they could give you pictures and they look very similar. Count the boxes. Count the boxes or those little tick marks to make sure that it's not crossing a 3, but it's crossing a 2.
Okay.
Or like this one.
Professor.
Yes.
Sorry to cut you, but on the practice test that you gave us on Blackboard, it doesn't, one of the questions, it doesn't even at the 5, it's like above the 5, but it's not on the 6 either. So it will look like 5.5.
Do you have that question?
Yeah, I got that question, but I didn't like screenshot it or anything.
What was?
Yeah, it was 6.
What was the? I have to agree with you, Stacy, in terms of something that this bothers me also. I sometimes find that their pictures of their graphs on the tests are not that clear. Um, if you come across something like this on the final and you're not sure what to do, email me and I'll look at it. And
All
I'll-
right, no problem, Professor.
because I understand you might know what to do, but you can't figure out from their picture because the picture isn't clear. If you have a problem with that, just let me know.
Okay, no problem.
Okay, but you understand this. Notice it, what they would probably have is one, they might have one picture, two pictures going this way and two pictures going this way. So you have to remember when it crosses the y-axis and when it crosses the x-axis. You okay with that? Should I do one more like this? Or it's not necessary?
Yeah, you could do one more, Professor.
Okay, let's do another one. Okay, what if I gave you this one? 36x squared minus 4y squared equals 144. Okay, I'll give you a couple minutes to work it yourself and then I will go over it. Okay, let's work on this. This one also has an x squared and a y squared and a minus in between them. So it's definitely a hyperbola. When you have an x squared and a y squared with a minus in between them, it's a hyperbola, but it's not in what we call standard form. Standard form is when it equals 1. So I have to divide everything over here by 144. And I have to reduce this. Now 36 into 144 goes 4 times. So that gives me x squared over 4. And 4 into 144 goes 4 and 36. And 144 over 144, of course, gives you 1. So I have to transform it from this format into what we call the standard format. And in this case, the x squared is the positive one, which means that we're going to have x-intercepts and not y-intercepts. The number underneath the x squared is what we call the a squared. That's equal to 4. So a squared is 4. So again, the a is either plus or minus 2. I always have to look either at the a squared or the b squared. Here the a is 2, so it's crossing the x-axis at 2, and -2. And now I make my two back-to-back U's. Here's one going this way and one going this way. Again, I have to look that it's crossing the x-axis now, and that it's crossing at 2 and -2. Is that clear now? Okay, so let's then do a question that has to do with the parabola and a question that has to do with a circle. And if we'll have time, then we'll do an ellipse again. We didn't do circles and parabola. So let's do that. Okay. Okay, suppose I gave you this, x squared plus y squared minus 4x plus 6y minus 12 equals 0. And this happens to be the equation of a circle because we have an x squared plus a y squared. There's no numbers in front of the x squared and the y squared. In other words, the x squared and the y squared have coefficients of 1 and they're both positive. That makes it a circle. The question is, find the radius and the center of the circle. See if you can find the radius and center of the circle. Okay, let's try this together. In order to find this, and when this is in the regular format of a circle, but we want to put it back into the standard format of the circle, which means the first thing we have to do is get the x terms together. So we're going to have the x squared and then -4x, and we're going to leave a space. Then we're going to put the y terms together. So we're going to have a y squared and a 6y. And any number that doesn't have an x or y next to it, we're going to bring to the other side. So we're bringing the 12 to the other side. Now, if you notice, I left spaces next to the x and the y terms because we're going to do this process of completing the square. Just like we did when we were solving quadratic equations. To complete the square, we take half of this number, the number in front of the x, which half of that divided by 2 gives me -2. And what you do with that number is you square it, you multiply it by itself. -2 times -2 is +4, and you add +4 over here. Now, of course, whatever you do to one side, you've got to do the other side in order to make sure that you're maintaining your balance. And then this expression, x squared minus 4x plus 4, becomes x minus 2 squared. Okay, now we do the same thing with the y's. We take the number that's in front of the y, so divide 6 by 2, that gives me +3, and multiply it by itself. 3 times 3 is 9. I've got to add 9 to both sides. And therefore, this becomes y plus 3 squared. Now, of course, there has to be a plus between the two. And now I just add all those together. 12 and 4 is 16. 16 and 9 is 25. This is the standard format of a circle, where you have x plus something squared, y plus something squared equals a number. And sometimes this is not, maybe this is just, if there weren't any extras, it might be just a plain x squared. But what you do is to find the center of this circle, you take the number that's in the parentheses with the x, switch its sign. This is a -2, so the number becomes +2. That's the x of the center. For the y of the center, I take this number, switch its sign, and that gives you the y of the number. So 2, -3 is the center of the circle. And the radius of the circle is the square root of this number. The square root of 25 is 5, so our radius is 5. So what we have to do is complete the square so we get our equation in standard form so we can read what the center and the radius is. Any question about that? Okay, so let's do one that involves a parabola. Now, a parabola is the only equation that we have, only quadratic equation that only has x squared and doesn't have y squared. Alternatively, it could have a y squared but no x squared. It doesn't have both an x squared and a y squared. Only one of the variables has an exponent of 2. One doesn't and one does. That makes it a parabola. Now, remember, a hyperbola was like 2 back-to-back u's. A parabola is just a single u. And sometimes the u opens up and sometimes the u opens down. It's a single u. We're not going to even talk about the ones that there could be sideways u's, but you don't have to worry about those. Okay, I'm going to erase this and I'm going to put an example with a parabola. Suppose I give you that y equals x squared plus 4x plus 5. Now I know this is a parabola. Even if they didn't tell me, I know it's a parabola because I see an x has an exponent of 2, even though one doesn't. Well, there is an x squared in it, but there is no y squared. There can't be both of them squared. This is what makes it a parabola. Okay, what you were usually asked to find on a parabola is what's called its vertex. I'm going to give you a couple of minutes to see if you could figure out the vertex of this parabola. See if you remember how to do the vertex. Then we'll do it together. Okay. Let's do this together. Remember, there's a formula for figuring out the vertex of a parabola. That formula goes like this: x equals negative b over 2a. And you must know this. Nobody's giving you this formula. You have to know this formula. Now, that doesn't give you the vertex. It just gives you the x of the vertex. And then you have to figure out the y separately. In this particular example, my a happens to be equal to 1 because there's no number there. And my b happens to be equal to 4. So to find the x of the vertex, we do negative 4, that's negative b, over 2 times 1, which gives me negative 4 over 2, which is negative 2. Now don't stop here because that's not the vertex, that's just the x of the vertex. To find the y, you take this number and you stick it into your equation. So you're going to do, instead of x, you're going to do negative 2 squared plus 4 times, here's my x is negative 2 again, plus 5. Now negative 2 squared is 4. 4 times negative 2 is negative 8, plus 5. Add this up. 4 minus 8 is negative 4. Negative 4 plus 5 is 1. So my vertex is the point negative 2, comma 1. That's your vertex is your most important point because that's the place where it's also called the turning point. In this case, my parabola would look a little approximately like this. Here's the negative 2, 1, which is right here. And we're told that's the vertex. Also, the a is a positive number. When the a is positive, when the x squared term is positive, it opens up. It's a smile. So you're getting something that looks like that. That's what your parabola would look like. Again, if they ask you for the graph of the parabola, find the vertex. And remember, does it open up? Is the x squared positive? Then it's a smile. If there's a minus in front of the x squared, if it's negative, then it's going to be a frown. Okay. Does anybody have any other questions they'd like me to go over? If not, I think I'm going to end class now. Anybody, if you want to talk to me personally or privately, or if you want to just stay on and ask me an individual question, I'll stay on for a few more minutes, but the rest of you can leave if I'm going to stop the recording and I'm going to I'm going to dismiss you. Don't forget to be on time for that final. I know you're doing it on Blackboard, but you want to be able to have the full 2 hours. Don't cut yourself short. And again, I will be available then. If you run into any problems, I will reset it. And if it turns out that I have to reset it and you have to start all over again, I'll give you enough time to finish so that you'll get your full 2 hours. There are 30 questions. I know the practice final had 40, but on the actual final, there are 30 questions. Again, it's very important for you to get used to doing the examples. Make sure you do those practice tests on Blackboard so that you are familiar with how to do it. I know you've done the midterm on it, and most of you have done at least 1 or 2 of the tests on, but do it. It gives you confidence that you know what you're doing. Okay. Have a
like I said, sorry, like I said before, thank you for being patient with us and being a good teacher and providing us the space to grow and evolve as students. So
Okay, I
thank you
wish
for that.
you all the best of luck the next term. You should all be successful in what you're doing. I have to tell you, CUNY has gone through a lot of different phases, but I got my degree, it was at Brooklyn College, there wasn't even a Medgar Evers then, but my parents had come from Europe, they had, with no money, there was no way they would have been able to pay for an education. The city university has provided an opportunity for so many of us to grow and get and accomplish. Yeah. Have a good best of everything to everybody. If there's no more, then does anybody want me to stay? And thank you, Corey. Thank you for giving us the heads up on the calculators. I learned from my students, probably more than you learned from me. I learned from you, and just I wish you the best and lots of luck in your future professions. Just you should be successful, and success comes from perseverance. Just keep working, because that's how you're going to be successful. Bye-bye. And so I'm going to end, if nobody wants me to stay.
I want you to stay, Professor. Can we do one more of those problems?
Okay, sure.
Yes, Professor, I have one example.
Okay. What, Devana, what would you like me to do?
I would like you to do one more of these problems, please.
What, on the parabola?
Yes.
Okay, suppose I gave you this question. Suppose I told you that we have y equals 2x squared minus 6x plus 11. Okay, see if you could find the vertex of that parabola. Okay, I'm going to give you a few minutes to try it on your own. Okay, Devana, let me know when you're ready.
I'm ready, Professor.
Okay, you're gonna walk me through this. How do I find, what do I have to do to find the vertex? What's my formula? Hello?
X equals
X equals,
negative B over 2A.
right. Thank you, Lucia. Okay, what is the A here? What is A in this particular?
2.
A is 2, because that's a number in front of the x squared. And what is B?
Negative 6.
Right, that's what's in front of the x, which is negative 6. So we're going to get x equals negative 6. There are two negatives here, because this is negative b, and the b itself is negative. So we're doing a negative of a negative 6 over 2 times a, 2 times 2, which is, so therefore we get negative and negative is positive 6 divided by 4. And we could reduce that to 3 over 2. So far, okay? If you were doing this on a multiple choice test, which is what you're going to be doing it on, I would first look at all the points. And if only one of them has an X value of 3/2, you don't have to bother anymore with finding the Y, because that has to be the right answer. But in this case, and also it could be written in fraction form 3/2, where if you put it in your calculator, you get 1.5. If you want to find the Y, this one's a little bit harder because you have fractions. You're going to have to put in place of the X, 3/2. So this is going to be 2 times 3/2 squared minus 6 times 3/2 plus 11. And you could just stick this right into your calculator. Here's my calculator. I don't have it with me.
It's -5.
Comes out to -5.
Yes.
Okay, let me see if I can do it without a calculator. Let's see.
Okay.
3/2 squared is 9/4. So this is 2 times 9/4. This is minus 18/2. And this is plus 11. Okay.
Oh, I made a mistake.
Okay. They won't give you one with fractions, so don't worry about it. But if they do, you could just stick it into your calculator. Let your calculator do the work for you. Okay, and instead of putting in 3/2, you might want to put it in 1.5 because that would be easier. Okay, 2 times 9/4 is 18/4 minus 18/2 plus 11/1, and my common, and I can reduce this 18/4. I'm going over here. The 18/4 becomes 9/2 and minus 18/2. And 11, I also want to put it with a denominator of 2, so I have a common denominator. 11/1 is 22/2. And now I add the numerators. 9 minus 18 is -9. -9 plus 22 is 13/2. So your vertex is 3/2 for the X and 13/2 for the Y.
Thank you, Professor.
Okay, just don't forget that formula. Next.
Okay.
Any other questions? Okay, so then I'm gonna wish you all a good.
Yes, I have one question.
You have a question? Okay, great. Okay, I'm erasing this then. Yeah, Nishia. I mean, Zia.
Yeah, I'm coming. Okay. X over X minus 2 minus 8 over X squared minus 4.
And they want you to combine it? Is that what they want you to do?
Yeah, they say express.
Okay.
Express.
Okay, so this is, we're subtracting two fractions, and in order to subtract them, we have to have a common denominator.
Yes.
And in order to find the common denominator, I first factor the denominators. Now this is already X minus 2, so I don't have to do anything with it. But the X squared minus 4, I factor to X minus 2 and X plus 2. So first I factor all my denominators, And then, if you remember, what I do is to find the common denominator, go to my first fraction and I circle that denominator. Everything, if there are more than terms there, I circle all the terms, all the factors. Then I go to my second fraction and I'm sorry, this one of these is supposed to be a plus. They're not supposed to be both minuses. One's a plus and one's a minus. The first one I have is an x plus 2. I don't have x plus 2 circled, so I circled that. But I already have an x minus 2 circled, so I don't have to circle that. If I take all the things that I circled, the x minus 2 and the x plus 2, that becomes my common denominator. And I'm going to rewrite each of the fractions with that denominator. So I'm going to have to get an x minus 2 and an x plus 2 for both of these. So if I compare this, here I have x minus 2, that I have. What I don't have over here is x plus 2. This thing, this is what I have to multiply by. I have to multiply by x plus 2. I have to take this x and multiply by the x plus 2. The x minus 2 was multiplied by the x plus 2. The x has to be multiplied by the x plus 2 as well. So that's going to be x times x is x squared, and 2 times x is 2x. Now over here on the second fraction, I have the x plus 2, and I also have the x minus 2. I didn't have to change that denominator at all. So I don't have to do, I didn't do anything to the bottom. I'm not going to do anything to the top. So far, okay, Azia? Azia, do you follow this so far?
Yes, Professor. Yes.
Yeah, okay. So now, since they have the same denominator, I can just put them all over one fraction. X squared plus 2x minus 8, all over the x minus 2 and the x plus 2. I just combine all the terms together and put it over one fraction, one denominator. And then I factor this. Now the x squared plus 2x minus 8, I know I'm looking for two numbers that multiplied a negative 8. Mommy. When I subtract them, it's going to give me plus 2. Well, if I subtract, I'm sorry, when I multiply them, they're going to give me 8. And when I subtract them, they're going to give me 2, positive 2. And I know that's got to be 4 and 2. So I can factor this to x plus 4 and x minus 2. You following that?
Yes.
And that's over x minus 2 and x plus 2. And what can I cancel out? There's an x minus 2 on top and an x minus 2 on the bottom. So my final answer becomes x plus 4 over x plus 2. You have to be very careful with the signs here.
Yes. Okay. Thank you.
Any other questions?
No, thanks.
Okay. Okay. Have a good weekend, everybody. I'm closing this now. Cancel the.
Thanks, Professor. Same to you.
Good luck. I'm
Thank you.
working on a lot of.
Thank you.
things.
Bye-bye.
Bye-bye. Bye-bye.